In this video, let us continue to solve problems based on the first principle of mathematical induction. Alright, here we've got the question which says, prove by the principle of mathematical induction that for all values of n belongs to natural numbers that 1 plus 4 plus 7 plus plus 3n minus 2 equals half times n times 3n minus 1. So let us look into how do we go about solving this problem, alright? So what we have to do first of all is let P of n be the statement 1 plus 4 plus 7 plus plus 3n minus 2 equals half times n times 3n minus 1. So now, in the place of n, let's substitute it by just 1. P of 1 is 2. Now, when it is n, it can just go on and on and on. But when we substitute it by 1, left-hand side just stops at 1. It doesn't go on further because it's just 1, right? Now, we'll see if this is equal to this one by substituting 1 in the place of n. Let's see if that satisfies it. So here we are. Half times 1 times 3 times 1 is just 3. So 3 minus 1. So we have half times 1 is just half times 3 minus 1 is 2. So 2 and 2 gets cancelled. So therefore, we have P of 1 is to 1, or P of 1 be the statement that 1 equals half of n times 3n minus 1, and that is equal to 1. So hence proved. So now we can go ahead to the next step. So now what we've done by doing this step is that this is a valid equation for 1. That's the first step. The next step is an assumption, all right? So the next step would be, we have to assume that P of m, just like how P of 1 was true. Now, once this is satisfied, we say that P of 1 is true. Just like how P of 1 is true, now we have to assume that let P of m be true, which means, now we need to assume that let P of m be true, which means, now let P of m be the statement which states that 1 plus 4 plus 7 plus plus 3m minus 2. In the place of n, we are substituting it by m equals half times m times 3m minus 1. Alright, so let us assume that P of m is true. So once we've assumed that P of m is true, we have another step. Now that we proved or assumed that P of m is true, now we have to prove that. Not that we have to assume, but we have to show or prove that P of m plus 1 is true as well. So now what happens for P of m plus 1? This is what happens. For P of m plus 1, let me write it here because we won't be having the space to write it in the same line, alright? So we have 1 plus 4 plus 7 plus plus 3 m minus 2. Now you know that the last term will be n, right? The before term will be n minus 1. But if it is n plus 1, it will be the next term. Same thing for m as well. M will be the last term. M plus 1 will be the next term. So here it is. Plus 3 of m plus 1 minus 2. Now, since I've used a curved bracket here, let me use a square bracket here, so that you can just, differentiate that. All right. So now this is equal to half times, in the place of n, it will be replaced by m plus 1. Or in the place of m, it will be replaced by m plus 1. Half times m plus 1 times 3 times m plus 1 minus 1. So this is what it is. So now if you see, if you take this statement, just take this part, you can see that it's the same as this, right? Now this is equal to half times m into 3m minus 1. So let's replace this part of the statement by half times m times 3m minus 1 plus 3 times m plus 1 minus 2. So now what we'll do is, now that we've replaced this by this, now we need to work from here and come down to this. Or what is it? The right hand side, to prove that, P of m plus 1 is true. So let's do that now. So now let's just solve this. So let me just continue the next step here. So that will be half times m into 3m minus 1 plus, so here it will be 3m plus 3 minus 2. So 3m will be one term and 3 minus 2 will be just 1. So that will be 3m plus 1. So here we've got it. So the next step is going to be, we'll just continue from here, all right? So it's going to be half of 3m square minus m plus 3m plus 1. So this is almost like, 3m square minus m by 2. I mean, it is the same as that, just written differently. So let's take LCM. Let's consider these as fractions. So this will be by 2 and this will be by 1. So that will be equal to 3m square minus m divided by 2 plus 3m plus 1 divided by 1. All right. So this is nothing but just this statement rewritten in a different way. So now taking LCM, I think now we'll know what it is all about. It'll be 3m square minus m plus this will be multiplied by 2. So as this. So that'll be 6m plus 2 divided by 2. So this 2 will be taken out is half. It can be written like this. Half times 3m squared minus m plus 6m plus 2 is what I'm doing. The next step is going to be half times 3m squared. 6m minus m will be 5m, so plus 2. So 3m squared plus 5m plus 2. Now, this is a quadratic equation. Solving the quadratic equation, we get half times 3m squared, so okay, 3 times 2 will be equal to 6. So we need to split the middle term in such a way that the sum gives you the middle term, the product gives you 6. So that will be 2 times 3, right? So we'll have 3m squared plus 3m plus 2m plus 2. So we've split 5m as 3m and 2m. Well, if you've got any doubts in what I've done here, please do go visit the quadratic equation video to try and understand the basics of this. So here we are now solving this equation. We have half times m plus 1 times 3m plus 2, which we can write it as half times m plus 1 times 3 into m plus 1 minus 1. You just split this 2 into 1 and 1. So now we're going to write this equation as this, 3m plus 2 is going to be written as 3m plus 1 minus 1. Because if you just solve this, you're still going to get 3m plus 2, because 3 times m is 3m, 3 into 1 is 3, 3 minus 1 is going to be 2. So the reason we are writing this is to show this is of what form? This is of this form, right? So that's the most important thing. So what we are trying to show is the n is simply replaced by m plus 1, which goes on to show that p of m plus 1 is true. So hence we proved by the first principle of mathematical induction that 1 plus 4 plus 7 plus dot 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 plus 3n minus 2 equals half times n times 3n minus 1. Alright, so that ends this problem as well as this video. I'll see you in the forthcoming videos with more problems based on the first principles of mathematical induction.